553. Can you pray? Can you pray? 26553. Kindly pray before we begin the lesson today.
Let us pray. Oh Lord Father, we come before you this morning. Thank you for the gift of life, protection, and guidance. We pray that during this lesson, we may be able to understand all that we are taught and be able to know what we are being taught. And it is in Jesus' name I pray and believe. Amen.
Amen. Thank you very much. We can begin our lesson so that the rest will find us as we proceed. Towards the end of term exam, as we were revising with my classes, they kept requesting that we do linear motion, and I thought it wise that we begin with the linear motion today, as you also type for any other topic that you would wish to us to handle in the near future. We'll cover as much as possible because we are revising. We'll move very fast in the introductory part of this topic because the introduction is more of definitions of terms and formulas. Linear motion is a topic where, when you know the definition of some terms, you will probably know the formula related. Or if you know the formula, it will be very easy for you to define. For example, the terms related to this topic, some of the terms related to this topic are distance, we have acceleration, we have velocity, we have displacement, and those all those terms, the way you define can also give you the formula. So we'll move very fast in definition of terms because you know we are targeting the part of calculations, the three equations of linear motion, where I saw a good number of you still had problems even from the end of term 3 exams. Therefore, we will move very fast in this other part. Then we spend some more time on that part. And as usual in physics, as we define some terms or all the terms, you must also give us the SI unit of the term you define. For example, if we ask you to give us state the meaning of distance or displacement, giving its SI unit, it means stating the term and giving its SI units will be 1 mark. If you forget to indicate that the SI unit, you'll miss a mark there. So let us begin from the simplest term, distance. Even from other subjects like mathematics and even biology, the definition of distance is still the same. The actual length covered by a moving body, and its SI unit is meter. Displacement, the difference between distance and displacement is that displacement is a distance moved by a body in a specified direction. So for distance, there is no specific direction, but for displacement, it is the distance moved by a body in a specified direction. When we'll be handling the motion graphs, the diagrams of the graphs will, the definition of these terms will also help us in motion graphs. You will realize that the graph of distance against time will not be the same as the graph of displacement against time. Another very important definition in this topic is speed. Speed is the distance covered per unit time. Now, if you know the definition that speed is a distance covered per unit time, per means divide or over. So the speed is defined as the distance covered per unit time. And that definition can give us the formula S, which is speed is equals to distance over time. For displacement, we said the displacement is a distance covered in a specified direction. We go to, so the introduction part of this topic, we begin from the definition, then we give the related formula, then we do some calculations. So every part of it has some calculation parts where we must solve some problems. Velocity. Velocity can be defined as the change of displacement per unit time. And the symbol for displacement in linear motion, displacement, the symbol is S. Normally, students tend to confuse between the symbol and the SI unit. The symbol of SI unit is different from the SI unit. For displacement, the SI unit of displacement is meter in words, but the symbol of the SI unit is M. Now, from the definition of velocity, the change of displacement per unit time, and we represent displacement as S, meaning the formula will be V the formula will be V for velocity is equals to displacement S over time. Then, in this topic again, it is very important to recall scalar quantities and vector quantities. In Form 1, we differentiated between scalar quantities and vector quantities. Can you react by, can you state or differentiate scalar quantities and vector quantities in the chat session? And state some examples. And state some examples of scalar and vector quantities. It will be very important to remember this. You'll see the importance of knowing scalar examples of scalar quantities and vector quantities, especially when we will be dealing with the motion graphs. Scalar quantities and vector quantities were done in Form 1. Ian Bui, you can also unmute your mic and respond to the question.
Scalar quantities. Scalar quantities are those that have magnitude only, for example, time, while vector quantities are those that have magnitude and direction, for example, velocity.
Thank you very much. Velocity is a good example of vector quantity. So in graphs, you'll come and notice that graphs of vector quantities are described using vector quantities, and graphs of scalar quantities are described using scalar quantities. We go to acceleration. Acceleration is another term that if you know the definition, you will also know the formula. And acceleration is defined as the change of velocity per unit time. When we say the change of velocity per unit time, what comes in your mind when we say change in y, in mathematics, change in y over change in x? Meaning, we have two values. For this case of acceleration, where the definition is the change of velocity per unit time, and the acceleration is a vector quantity. So change in velocity means we'll have the final velocity and we'll also have the initial velocity. So you can now see how the definition can also give you the formula, which is acceleration is the change in velocity, and the change in velocity is final velocity minus initial velocity, then per unit time, which is over the time taken. This introductory part is very important. It is forming the basis of some, it will be easy for you to understand some concepts here after knowing the basics in this topic. Let us now, I am sharing the screen. Can we begin from number 6? I hope you can see what I've shared in, I have shared the screen with the question 6 to question 10. With the question 6 to question 10. Question 6, a bus accelerates from that 6 kilometers per hour to 72 kilometers per hour in 15 seconds. Determine the distance covered. In this topic, I'll advise you to be making some brief notes using the, for example, you identify or you analyze the data given the question. For example, that 6 kilometers per hour and 72 kilometers per hour. For this case, that 6 kilometers per hour will be the initial velocity, and 72 kilometers per hour will be the final velocity, and 15 seconds will be the time. When you analyze the data and make some brief notes before answering these questions, it will suggest a certain formula. It will suggest a certain formula. Now, you must, it is not a must that you use this. There are many methods of getting, there are many ways of killing a rat in this, in every question here, meaning we have various methods of getting the same answer. So we have that 6 kilometers per hour and 72 kilometers per hour. But it is important for, it is always important to change the units into their SI units before calculating, before giving the answer. For instance, that 6 kilometers per hour and 72 kilometers per hour can be changed into meters per second. 15 seconds is okay because the time, the SI unit for time is seconds. So can we now change the 6 kilometers and 72 kilometers into meters per second? We'll get, for that 6 kilometers per hour, we get 10 meters per second as seen. Then for 72 kilometers per hour, we get 20. Now, we also have 15 seconds. We have the initial velocity u, and we have the final velocity v, and we have time. Now, distance, determine the distance. Distance is also displacement, but we said the displacement is for a specified direction. And we said we can, we have the three equations of linear motion. We have the three equations of linear motion, which you must know without referring. By now, you should know the three equations of linear motion without referring to your books. Can you try in your exercise book to write the three equations of linear motion? Because in these calculations, you will you apply one of it. If you use the formula, let me try to. These are the three equations of linear motion. Number one is gotten from the formula of acceleration, which is also a possible question. Can be told to show that V is equals to U plus AT, 3 marks. Can be told to show that U is equals to, or that V is equals to U plus AT. So for this case, you will write the formula of acceleration. You begin from the formula of acceleration. Then you make V the subject of the formula, where we can begin by eliminating the denominator, which is T, time. Then we multiply T to both sides of the equal sign. We'll get you multiply T to both sides of the equal sign. From that first step, you get AT will be equal to V minus U. Then you take U to the other side of the equal sign. You get V, and therefore V will be equal to U plus AT. So generally, you must know the three equations of linear motion. The second equation of linear motion is S is equals to UT plus half AT squared. S is equals to UT plus half AT squared. And the third one is V squared plus U squared plus 2AS. If you're not asked to show that, for example, V squared is equals to U squared plus 2AS, we'll be given calculation questions to use the three formulas. In deriving the second one, S is equals to UT plus half AT squared. In deriving the second one, S is equals to UT plus half AT squared. You begin by the by giving the formula of displacement, which is velocity, average velocity multiplied by time. And the average velocity is the initial velocity plus the final velocity over 2. That is now the average velocity multiplied by time. But we know that velocity, or V, is equals to the initial velocity plus AT. That is from the first equation of linear motion. Then we now substitute, where we have V, we substitute with U plus AT. That will give you this second equation of linear motion. For the third equation of linear motion, we also use the formula of displacement, and displacement for this case will be like that of mathematics in Form 3. Displacement can also be gotten from the area under graph, and the unit is meters. When you are given the calculation to calculate the area under graph, calculate the displacement in mathematics, we saw some of you giving the unit as meter square. But displacement, when we say area under graph, is the same as displacement, and the question is asking displacement, you give the value in meters. Now from equation 2, which is S is equals to UT plus half AT squared, from equation 2, which is the formula for displacement is average velocity times time. But we know that when we rearrange the equation 1, which is v is equals to u plus at, then we take v minus u to the other side of the equal sign. Then the other side will be, the equation we get will be v minus u is equals to at squared. At. We substitute. We now substitute to equation 2 displacement, which is s. In equation 2 in linear motion, s is equal to ut plus half at squared. We now substitute where you have a u, we substitute with let me try to scribble, to write something on so that you follow. In simple terms, in deriving equation 2, we replace t. And the first, we can redo it. Equation 2, we want to get, we want to show that v squared will be equal to u squared plus 2as. We want to show that v squared is equals to u squared plus 2as. So we first write the formula of displacement, which is displacement is the average velocity multiplied by time. When we write it as a formula, it will be s is equals to v plus u over 2 multiplied by t. Then we replace t, or we make the first equation v is equals to u plus at, we make t the subject of the formula. And if we make the t the subject of the formula in the first equation, we will get t will be equal to v minus u over a, when we make t the subject of the formula in the first equation of linear motion. Now, we now replace where t is with v minus u is over a with the t. So where t is in the first formula of displacement, we replaced with V minus U over A. Then we now open the brackets. So when we substitute S with the T we have derived here, which is T is equals to V minus U over A, we get that S, which is displacement, will be equal to V plus U over 2 multiplied by V minus U over A. Now, when we open the brackets, that is the same as factorization in mathematics. You can use any other method to either long method, or you apply the three identities from mathematics to open the brackets. We can also find the LCM of the denominator. The LCM of the denominator will be 2 and A. When we use the long method of finding the LCM, someone is raising the, who is this? Who is this? Oh. So we continue. So we can make, we can find the formula, the LCM of the denominator 2 and A, which will be, the LCM will be 2A. Then V plus U multiplied by V minus U. If we use identities, those are difference of two squares, it will be V squared minus U squared. Or you can even use the long method, V plus U, and then V minus U. V into brackets, V minus U, plus U into brackets, V minus U. You'll finally get, when you collect the like terms, you get S is equals to V squared minus U squared over 2A. When you cross multiply, as we try to eliminate the denominator, you'll find that you'll get 2AS is equals to V squared minus U squared. Then we now make V squared the subject of the formula by taking minus U squared to the other side. We get a formula V squared is equals to U squared plus 2AS. So it is a possible question. It is a possible question. You can be asked to show that V squared is equals to U squared plus 2AS. 3 marks. Albert? Now we go to calculation questions from the same. Question number 1. A body is uniformly accelerated from rest. When we say a body is uniformly accelerated from rest, it means rest. So depending on the question, rest can be the initial velocity, or it can also be the final velocity. So rest has a value, and the value is 0. In most cases, the value is 0, because if you are not in motion, if you are, if a body is resting, it means there is 0 motion there, 0 meters per second. So a body is uniformly accelerated from rest to a final velocity of 100 meters per second in 10 seconds. Calculate the distance. Before Before we do this question, let us try to analyze the question and see the values we can get from the question, because those the values or the terms we get from the question can lead us to a certain formula from the 3 equations of linear motion. We begin. A body is uniformly accelerated from rest to a final velocity of 100 meters per second. So the final velocity v will be equal to 100 meters per second. Then 10 seconds will be t. Then the rest now, it is starting from rest. Rest will be the initial velocity u. Don't also forget to, the question is calculate the distance. The distance can also be the displacement. So we'll indicate S and put the question mark there. So we have 4 values. We have u is equals to 0 meters per second. We have v is equals to 100 meters per second. And we have t is equals to 10 seconds. And we don't know S. The short notes have already suggested the formula. One of the formulas in the 3 steps of the 3 equations of linear motion, which is either S is equals to ut plus half at squared, or v squared will be equal to u squared plus 2as. Now, that is from the notes we have taken before calculating the equation. Then we check if v squared plus u squared plus 2as will give us the answer, or S is equals to ut plus half at squared will give us the answer. We have u. Let us check from the formula S is equals to ut plus half at squared. We have u, we have t, we have do we have a? We can get a by finding the average velocity per unit time. Can get a by finding the average velocity per unit time. Then t squared. We have t. So we can use both. Let us check v squared. V squared is equals to u squared plus 2as. If we can use the same formula in this same question, we have v squared, which is the final velocity. We have 100 meters per second. We have u, which is 0. We have a. A can be gotten by using the formula average velocity per unit time, which is 100 minus 0 over 10. And we have S. Do we have S? We don't have S. Now, if we have all the values except S, it means we can get S. So we can use any of the formulas to find the distance covered this question. So a body is uniformly accelerated from rest to final velocity of 100 meters per second in 10 seconds. Calculate the distance covered. We have u, which is, so we use the formula S equals to ut plus half at squared. We have u, which is 0. 0 multiplied by anything is 0. Plus half multiplied by. Now, if you don't follow this part of A, how are we getting A? We know A is equals to V minus U over T. Acceleration is equals to final velocity minus initial velocity over time. That is why we are saying 100 minus 0 over 10. 100 minus 0 over 10 is the acceleration from the formula of acceleration, multiplied by T, given from the equation, 10 multiplied by 10. We now substitute and we get the answer to be 500. Those who are using Those using v squared is equals to u squared plus 2as. Are you getting the same answer as 500? Can I get the response from the chat session? Those who use the formula of v squared plus 2 v squared plus v squared is equals to u squared plus 2as. Now, number 2, a body whose initial velocity is 30 meters per second moves with a constant retardation. Retardation is the same as deceleration, meaning retardation or deceleration has a negative value. Deceleration or retardation has a negative value. It is the opposite of acceleration. So acceleration has a positive value. Retardation, which is also the same as deceleration, has a negative value because it is moving in the opposite direction. We have the deceleration of 3 meters per second squared. Calculate the time taken for the body to come to rest. Calculate the time taken for the body to come to rest. Meaning, rest for this case will be the final velocity 0. And a body whose we have the initial velocity of 30 meters per second. And we have retardation, which is negative 3, because it is moving in the opposite direction. So we substitute. We already have v, we have a, and we have v, the final velocity. From those brief notes, we will realize that we'll be using the formula v is equals to u plus at, because we have all the values except time. For this case, we cannot use the third equation, v squared is equals to u squared plus 2as, because we don't have s. Example number 18, a body moving with uniform acceleration of 10 meters per second covers distance of 320 meters. So this 320 meters is s, the displacement. And the acceleration is 10 meters per second squared. If its initial velocity, we have u is equals to 60 meters per second, calculate its final velocity, meaning we don't know v. So if we don't know v, we are likely to use equation number 1 or equation number 3, which is v squared plus, is equals to u squared plus 2as. From our brief notes, from the question, we notice that we have a, which is 10, we have s, which is 20, but we cannot use the first equation because we don't have s. If its final velocity is 60 meters per second, we have v. If its initial velocity, u will be 60, we don't have v. So those analyses leads us to use the equation number 3, which is v squared is equals to u squared plus 2as. I want us to now try, before we continue, try to do this. Let us try these questions here. I'm sharing some questions related to that concept. Number 3 and number 4. A boulder is sliding down a slope with a uniform acceleration of 3 meters per second squared. Calculate its velocity after 10 meters down the slope. So this question, we have the acceleration, which is 3 meters per second squared. We have S, which is 10 meter down the slope. Can you calculate the velocity? How will we get the velocity? Can we try number 3? Then you type the answer. Then you type the answer. Can we try number 3? A boulder is sliding down a slope. Make sure you indicate the formula and answer with the correct units. Answer with the correct units. Number 3 and number 4. Give me the answer. Begin by scribbling some notes before calculating it. Begin by analyzing the question. Ivan? Albert? Albert? 26, 6, 25? You want to say something? That is 26, 6, 25. You have the answer?
Yes.
Yes, what
For
is the
number
answer?
3.
Uh-huh.
Number 3, I have 7.746 meters per second.
7 point. Can you briefly explain how you got the answer?
Since we asked the velocity after it has slid down the slope, that means we're being asked for the final velocity. I used the equation of linear motion that states v squared is equal to u squared plus 2as. U squared, I got 0. For 2as, I got 60. After getting that, I said v squared is equal to 60, then square rooted the answer to get 7.746 meters per second.
So you use the equation v squared is equals to u squared plus 2as.
Yes.
Yes, that is one of the approach. There is another approach. Is that Albert? You have another approach. That was a direct approach, which is also very correct. You can also use another approach, and you get the same answer. Any other approach? Any other approach? That is any other approach? You can also use, you can also begin by using S is equals to Bin Laden. You have something to say? You can also use the approach by starting with the formula S is equals to U T plus half AT squared. Try to use S is equals to UT plus half AT squared. Then you get a time. What do you get for time? If you use S is equals to UT plus half AT squared, you get it. That formula will give you the time. You get T is equals to T is equal to T is equal to 2.58 seconds. If you use S is equals to UT plus half AT squared, you get T is equals to 2.58 S seconds. Then you have T. You now have T. You have U. And you have A. From the question, we have A, acceleration, which is 3 meters per second squared. And we have T, which is 2.58. We don't have V. We can use the equation number 1. V is equals to U plus AT to find V, which is also 7.75. So in some instances, you can use two equations to get the answer. And you can also use one equation to get the answer. Number 4, a car can be brought to rest. What is the meaning of this statement? A car can be brought to rest from a speed of 200 meters per second, meaning 200 meters per second is the initial velocity, and rest will be the final velocity. Rest, which is 0 meters per second, will be the final velocity. For this case, calculate the average deceleration. Calculate the average deceleration. You must test yourself with these questions in order to know if you are understanding or not. I've already given the hints that a car can be brought to rest, meaning rest is the final velocity from the speed of 200 meters per second. 200 meters per second is the initial velocity, and we have T. Calculate the average deceleration. We're expecting a negative value. Minor Elvin, Gitonga. Minor Elvin.
The average deceleration is 100 meters per squared second. That is, the acceleration is negative 100 meters per squared second.
That is correct. If you give the answer as deceleration is 100 meters per second squared, now because it is acceleration and deceleration, the unit will be meter per second squared. So we expect the answer to have meter per second squared. If you indicate the deceleration is 100 meters per second, there is no negative sign. If you give the answer without deceleration, The answer is negative. Part 2, if the driver reaction time is 0.2 seconds, determine the shortest stopping distance. Determine the shortest stopping distance. Derek? Derek?
Teacher sijaelewa.
Or the first one, eh?
Yeah, sijaelewa hiyo ya kwanza.
The kwanza.
Yeah.
Sawa. So the first one, the question is,
Yes.
calculate the average deceleration. Now, what is the formula for acceleration? A is equals to
V minus
A is equals to V minus U over T. What is our initial velocity for this one? What is the initial velocity? A car is brought to rest from a speed of 200. So initial itakuwa 200, final itakuwa ngapi? 0. 200 minus 0 over 2. 200 minus 0 over 2. Hiyo ni ngapi? 100. That is how we get 100. Lakini deceleration iko na negative value. Kama umeacha tu ikiwa 100, itakuwa negative 100. Calculate the average, but the question has already asked for the calculate the average deceleration. So you indicate the deceleration is 100 meters per second squared. Derek? Derek, are you okay? We're using the formula for acceleration because acceleration, deceleration is the opposite of acceleration. Deceleration means the body is moving in the opposite direction. The body is moving in the opposite direction. Now, can proceed to let me give you two more questions on that. Let me give you two more questions. I'm sharing something. Question number 10. Question number 10. Can we do the question number 10? A car is brought to rest from a speed of 30 meters per second in 2 seconds. If the driver's reaction time is 0.3 seconds, determine the shortest stopping distance. determine the shortest stopping distance. Ivan, you have something to say? Ivan?
Sure.
Yes.
I wanted to ask about how do we go about number 4 Roman 2?
Number 4 Roman 2.
Save.
Let me check the question. Here is the question. If the driver reaction time is 0.2 seconds, determine the shortest stopping distance. This one is wrongly calculated. This one is wrongly calculated. So the reaction time is 0.2 seconds. We will make some brief notes as we did in the other questions. For this case, we have the final velocity. We have what is the final velocity? The final velocity was the final velocity was 0. The final velocity was 0 in the first equation. Then the initial velocity is u is 200. 200. Then we have the acceleration, or we have the deceleration, which is negative 100. Do you have distance? Now we are looking for the distance. We are looking for the distance. So if we make some brief notes from the question, and we have noticed that we have v, we have u, we have a, we don't have s. It means we'll use the formula v squared is equals to u squared plus 2as. Which is the same as we have v squared is 0 is equals to 0 squared is equals to u squared, which is 200 squared, minus we have the time 2 seconds multiplied by negative 100 multiplied by negative 100 multiplied by s. So we are looking for s. We are looking for s. So we'll use two formulas here. Distance, we normally know that distance is equals to speed times time. Distance is equals to speed times time. Now, in the first case, we have we can find distance here in equation 1. We have speed of 200 meters per second, and we have time 2 seconds. For us to find distance, it will be the same as speed multiplied by time, which is 200 multiplied by 2. And that is, we are getting 400 as a distance. In 1, we already have found the acceleration, which is negative 100, from the formula of acceleration is equals to v minus u over t. We got a negative 100. Then we are looking for determine the shortest distance. Determine the shortest distance covered. Na make some brief notes, tuko na V, which is 0, tuko na U, which is 200. We have A, which is a negative 100. We have A, which is negative 2, negative 100. We now substitute the values to find the distance. Can we substitute the values to find the distance?
Aye.
Meaning it would have covered 400 meters with a speed of 100, then it decelerates for another 200 meters. S will be, so according to this question, the answer will be 200. If you are asked the total distance, it will be now 200 plus 400, which is 600. So the answer is 200. Determine the shortest stopping distance. Another question on deceleration is number 9. A body initially moving at 50 meters per second decelerates uniformly at 2 meters per second squared until it comes to rest. Meaning rest will be the final velocity. We are in number 9. Ivan? Question number 9 also requires us to find the distance, and it has deceleration we have deceleration in the question, meaning we have some negative value. When you see deceleration in the question, when you see deceleration or retardation in the question, it means we have a negative value.
Terus lagi yung pala.
26,269. 26,269. Number 9, a body initially moving at 50 meters per second decelerates uniformly at 2 meters per second squared until it comes to rest. What distance, meaning at GS, Nandeka S is equals to S question mark. We have the initial velocity, which is 50 meters per second. We have the acceleration, which is 2 meters per second squared. And we have rest, comes to rest, which is 0. Those brief notes will lead you to this formula of V squared. V squared is equals to U squared minus 2AS. We have 17 minutes left. We'll do this one question on the ticker timer. One question on the ticker timer. Question number one. Question number one. The figure below shows a section of a tape. This one is drawn to scale. Let's do number two. The dots below were made by 10 tick timer of 100 hertz. Determine the acceleration of the body. We know the formula of acceleration is equal to v minus u over t. But before we use the formula a is equals to v minus u over t, we must find the values of the initial velocity and the final velocity, which is u and v. But we have been given that the dots below were made by 10 tick timer of 100 hertz. We have been given the frequency of 100, meaning we'll have to look for the periodic time, and the periodic time t is the same as the formula for periodic time t is 1 over f, the reciprocal of frequency, 1 over f. In other, sometimes you can be given other ticker timers ziko na 50, zingine ziko na 100. So you use the value in the question, which is 100. So for you to get the periodic time t, the formula is t is equals to 1 over f, 1 over frequency. That is the reciprocal of frequency. You get 0.01 seconds is the periodic time. That means that is the time between one dot, from one dot to the other. So we'll use that time to find the initial velocity and the final velocity. We have the distance of the initial velocity, which is 25 centimeters. If the question is not asking you to leave the answer in SI unit, which is meter per second, we can do the question as it is. We can leave the answers in centimeters. But you can also give the answer in meter per second square. If you are not asked to leave the answer in SI unit. Now, the initial velocity will be the distance between the first two dots, which is 25 centimeters, over the time between the first two dots, which is 0.01. So the initial velocity will be 22,500 centimeters per second. Those who are using meters per second will get 25 meters per second. Then the final velocity, the distance of the final velocity will be 45 centimeters over 0.01 seconds. But you can as well change 45 centimeters into meters, but you will get the answer in meter. Those who are using, that is the ENOS. You have something to, do you have an addition or a question or a comment? Is that ENOS?
So, is it over 0.01 or 0.09?
It is over 0.01. It is 1 over the frequency. What is the frequency? The frequency is 100. The
So
frequency
if you
is 100.
want to calculate the acceleration,
Yes.
do you say, if you want to calculate the acceleration, you'll say final velocity minus initial velocity over 0.01
time 0.01 or 0.09?
It is 0.01. We hatujafika hapo kwa kucalculate acceleration. We are still in the initial velocity and the final velocity. But these calculations able to confirm kama if the calculation is right or not. So we have the initial velocity. Are you getting the initial velocity to be 2,500 centimeters per second or 25 meters per second?
Yes.
The final velocity you are getting 45 meters per second or 4,500 centimeters per second. We have two marks. We have two marks here. Now, acceleration will be final velocity minus initial velocity over t. Now, we already have the initial and the final velocity, which is 4,500 minus 2,500. Then we have the time for one between two dots, which is 0.01. Eh? Now, hebu tuangalie sasa hapa. Tuangalie hapa sasa. From the initial velocity, tunaweka katikati, we subdivide the dots in the initial velocity hapa hivi, tunachora mstari katikati hapo na pale kwa final velocity katikati yake. Then we can there are several approaches of getting the answer from this. One of the approach is you can leave the initial velocity, achana na hizo the first two dots na the last two dots, kwa sababu complete spaces hapa. Complete spaces minus, can you count the complete spaces minus the initial and the final? Complete spaces minus the initial and the final velocity ni ngapi? 1, 2, 3, 4, 5, 6, 7. Are you getting 7? Complete spaces minus the initial and the final velocities. Then ukichora katikati ya final velocity na initial velocity, you unafanya half of the initial velocity, half of the initial velocity, half of 1, na huku tena ni half of 1. So initial velocity itakuwa na half na final, huko kwa final velocity itakuwa na half kwa sababu tumesubdivide. Na tulikuwa tumepata complete ni ngapi hapa? 1, 2, 3, 4, 5 complete spaces. 1, 2, 3, 4, 5, 6, 7. Tunaanzia wapi kucount? Mbele ya 25 na nyuma ya 45 hapa. Tunapata 7. Hizo ni complete spaces. Huko kwa initial 25 tunagawa katikati hapa. Hapa kwa final tunagawa katikati, meaning hapa kwa final na kwa initial itakuwa half of how many dots? Half of 1 hapa, half of 1. Itabaki kuwa half hapa na half kumwisho. So it will be 7 plus 1. 7 plus 1 itakuwa 8. So it will be 0.01 multiplied by 8. What is the answer? This is not the correct answer here. What is the answer? The projection is showing that we have a times 9. Times 9 spaces is not correct. Levin Masharia?
25,000 centimeters per second.
Yes. Are you getting, is everyone getting 25,000 centimeters per second? What is the value in meters per second? For those who use the SI unit meters per second. That is that Christian?
Yes, sir. I got 250 meters per second.
Meters per second. Can you briefly explain how you got? Can you briefly explain how you got 250 meters per second, especially the part where you have to count the spaces?
Okay. So
Begin from
the formula.
kindly begin from where you have used the formula acceleration is equals to v minus u over t.
Okay. So the formula is acceleration is equal to v minus u over t. So our initial velocity,
Yes.
our initial velocity will be 25.
Yes.
But we change just so it becomes 0.225 years. And our final velocity will be 0.45 meters. So according to our formula, we have to use v minus u over t. So it will be 0.45 minus 0.25 meters over. So the time sasa, we will count the spaces in between before we exclude the initial and the final. So we count the spaces in between the dots zenye ziko between ambazo tutapata ni 7, alafu
Yes.
we take the one space ya initial na ya final, alafu we divide by 2, we will get 1, so we will get 8 spaces.
Thank you very much. Any other varied explanation of the same? Any other varied explanation on the part of counting the spaces in the last part? Frank Mushangi? Frank Mushangi? So that is it. Can you try number 5? The figure below shows a section. This is the last question. We have only 3 minutes to go. The figure below shows the section of a tape from take a timer of frequency 50. Determine the acceleration of the trolley pulling the tape. The first step is to find the periodic time. Periodic time t is equals to 1 over f. For this case, we have been given the frequency to be 50. So you'll use a 1 over 50. Then the initial velocity, because the question is not asking us to leave the answer in SI units, we can do it the way it is with the centimeters, which is 6 over the distance between two dots, which is 0.02. And you now have the initial velocity and the final velocity. I want you to give me the final answer. It is not necessarily, the answer here is not, might not be correct. Murero, you have something to say. Where are you? Where are you? What is the answer? 26, 6, 25. 26, 6, 25.
The answer is 15,000 centimeters per second squared.
Yes. You're getting 15,000. What is the number of spaces between the final and the between the initial and the final velocities?
Kindly
Makori?
repeat.
Yes. Makori?
Pardon the
Makori.
question. Yes,
The
pardon the
question,
question.
this is question number 5.
Oh, the number of spaces will be
1, 2,
6.
3, 4, 5.
Yes,
Yes,
5.
the number of spaces will be the complete spaces will be 5,
Yes.
and then another one.
Then you add half from either side.
Yes. So what is the final answer?
15,000.
15,000. Eh?
Yes.
Yes. So the time will be 0.2 seconds, regardless of the distance between the two ticks. Ikue refu ikue fupi, distance bado time bado itakuwa 0.02, alafu na multiply na the number of spaces. I'm sending the cut through the form master, then you try. I'm sending related cuts through the form master. Otherwise, have a nice time. Alpha.
Bwana Ropu umemaliza class? Ashatoka.